I think I remember hitting record. Okay, excuse me, sir, sorry. Okay, so number one needed to go into the category of like easy peasy, no problems for anybody, right? I'm curious, did anybody try factoring? A lot of folks tried factoring last period and they were like, it wouldn't factor. You're right, it doesn't factor. And we're not actually interested in if it factors or not, because if you just plug in, you get 10 over 2 and it's 5, that's good. Okay. All right, number two though, this is one where you've got to worry about factoring, because if you do direct substitution, you plug in, we get 0 over 0. Fancy word for 0 over 0? Begins with a 9. Ends in indeterminate form. And so the fancy word for 0 over 0 is? Oh my God, I cannot toss it any easier than that. The indeterminate form. The vocabulary is important. When I see 0 over 0, Kevin and friends, this is a sign I need to factor. So I factor the numerator, 3 minus t and 3 plus t. I factor the denominator, t minus 3 and 5t plus 4. The 3 minus t and the t minus 3 cancel, but they're not the same. They're not equal. They're opposites of each other, which is where we get this extra -1 showing up. So -6 over 19. All right, number 3. If you're getting any of these wrong, give yourself the feedback. Make the corrections. It's okay. Number 3, if you do direct substitution, 1/4 minus 1/4 over 0, 0 over 0, no bueno. Okay, we've not done one like this in class, but good news, you did with Mr. Link last year. The key here, when I see these two fractions, I want to get a common denominator so I can combine them into one fraction. X plus 4 and 4, the common denominator is going to be x plus 4 times 4. Multiply the top and bottom of the first one by 4. Multiply the top and bottom of the second one by x plus 4. Fancy one. Now that you've got the same denominator, you can subtract the numerators, and then divide by 1 over x means multiply by 1 over x. If all goes well, you get -1 over 16. How many guys honestly get -1 over 16? 1, 2, looks like 3 or 4. If you're not getting this one right, give yourself some feedback. You're not cheating. You should be writing this down in the notes. Yes, ma'am?
I got lost after -x over 4x plus 4.
The -x over 4x plus 4? So that was combining these two fractions up here. And then you have to divide by x. So to divide a fraction by something is the same as saying take that fraction and multiply by the reciprocal. Remember 6th grade? Keep it, change it, flip it?
Yeah.
Keep it, change it, flip it is what happened there. And then the x's canceled. Okay, number 4. I hope this one went well. This is the one I said was calculator active. I was expecting limit from the left. I'm expecting limit from the right. If all goes well, you got 1. Yes. How many guys got 1? I need the calculator skills to be strong here. I need to see the work. I need to see the stabilization. Okay, number 5 rocked the world last period. Number 5, if you just plug in, you get pi over 4 divided by cosine of pi over 4. And even if you don't know what cosine of pi over 4 is, I know it's not 0 over 0. So it's okay. It's okay to just do direct substitution. Cosine of pi over 4, you can go to the unit circle and square root of 2 over 2. And then it's happening again, Delia. Keep it, change it, flip it. Pi over 4 divided by square root of 2 over 2 is pi over 4 times 2 over the square root of 2. And then I think I reduced and I got pi over 2 square root of 2. Okay. Number 6 is just a whole lot of fancy algebra. To do x plus h cubed, you have to do the box. And then another one. Okay. You have to do a box over here. Things start to cancel, and if all goes well, you get 3x squared minus 4x. I'm curious, how many guys honestly get 3x squared minus 4x? Algebra skills are good. I'm looking for, though, are you keeping that limit notation all the way through? Because that's what's going to be the difference between like a perfect answer and a kind of okay answer. Jackie, you okay?
Oh yeah.
All right. Okay, number 7. Is this one that we need to talk about?
Yeah.
Okay, because this was the one where we had like 8 seconds left, and I was like, hey, this is going to happen! Go! Go home, watch the video. So can I get like a do-over?
Yeah.
Is everybody's okay?
Yes.
Ashley, you're okay? You look angry.
She just
Okay. All right, so here's the problem. If I said to you all for number 7, what's f of 1? I would hope this is like a 3-second problem. What's f of 1? F of 1, Kevin says, is square root of 3 over 2. We know the x value is 1. I want to know what is the y value at 1, and the y value is square root of 3 over 2. Easy peasy, right? Now, what's different though, when I say what's the limit as x approaches 1? I want to get some hands on this. What's different? I know it's a limit, but what's different? What's different about the question that I'm asking here, Jackie?
That it's not pushing.
You're not actually 1. What I'm asking here is what happens as
It approaches.
approaches, right? This approaches word is important to us. What happens as x approaches 1? Well, to approach 1, I've got to consider numbers less than 1, and I have to consider numbers greater than 1. Are we okay? So I have to split this and say, oh, what's the limit as x approaches 1 from the left? What's the limit as x approaches 1 from the right? If I'm approaching 1 from the left, which of the 3 parts? Left of 1. An example of a number left of 1? 0.9, 0.99, 0.999. First piece. So I need to know what's this limit. For the right of 1, I'm going to use the bottom piece. If I try plugging in now, I've got 1 minus 1 squared plus 1, which I think is 1. Limit on the bottom is the natural log of 1. Oh, so awkward. Natural log of 1 is not e. We have the cobwebs going on, I know. Natural log of 1. If you're not sure, use your calculator, that's fine. I will not judge. Yeah. Natural log of 1 is 0. So the conclusion, Eric, what is your conclusion here? What's the limit as x approaches 1?
The limit of f of x as x approaches 1 from the left side is not equal to limit of f of x approaches 1 from the right side. Okay,
the limit from the left and the limit from the right are not equal to each other, so your conclusion, what are you going to tell me about the limit as x approaches 1? Not undefined. Does not exist. Does not exist. And then because what Eric said, limit as x approaches 1 from the left is not equal to the limit as x approaches 1 from the right. And if you don't have that on your homework, fix it. Fix it, fix it, fix it. All right, and the last one, another mean one, kind of a throwback to pre-calculus. I'm just gonna leave that up there for a second. There we go, get some game here. Okay, you're given f of x equals the square root of x. We want the limit as h approaches 0 of f of x plus h minus f of x all over h. F of x plus h means take the x plus h and plug it into f everywhere you saw an x. So we get square root of x plus h. F of x, you're going to do the same thing. All divided by h. If you tried evaluating, you're going to get 0 over 0. Indeterminate form. So what you need to do is this is multiplying by the conjugate. It's that fancy one. And if you multiply this out, I wish I did this last period, because I think this is what blew their minds. Square root of x plus h minus the square root of x, square root of x plus h, plus the square root of x. I'm just multiplying out the numerator right now. Square root of x plus h, some square root of x plus h. Everyone's going to tell me? Is x plus h. square root of x plus h times the negative, I'm just going to write this as negative square root of x times square root of x plus h. I'm not going to try simplifying, are we okay? Just this guy times this guy? What about down here? The positive version? In this last box? Careful. Positive square root of x times negative square root of x is negative x. So what happens, this negative square root of x plus h and the positive square root of x plus h cancel. They always cancel. That's why we do this multiplying by the conjugate trick. It always works this way. And now you're left with x plus h minus x. Let me erase the rest of what's on the board. I think once you get past that, hopefully the rest is not too bad. Final answer, if all goes well, is 1 over 2 square roots of x. Okay. The 14 of you, but Ashley especially, look like you need some good news in your life. Anybody want a little bit of good news? Okay. I'm not going to pick this up for a grade today. That was the good news. That's all. That's all. That's all with the good news. I am not interested in picking this up right now. I will tell you that the homework that you're going to do tonight, if you could please write this down, it's on page 59 in the unit guide, that unit guide that you're bringing to class every single day. Carlos, you okay back there? You all right? So tonight, this is getting picked up tomorrow, so make sure that you heard that and you plan accordingly. Page 59, problems 1 through 12, is basically a do-over on this assignment. So this is an opportunity for you to take all the things that maybe you struggled with last night, fix it, turn this in tomorrow, know that I'm picking this up for a grade. One, you're good? All right. Roberto, we're okay? Ashley, you okay? I'm just using all the names now. Delia, are we still filming?
Yeah.
Do I look good?
Yeah.
In my new pants? Thanks. I don't buy new clothes often. You're going to see all the same polos that last year's class saw. All right. Trust me. You'll see the video and be like, oh, he really doesn't buy new stuff. All right, so that's tonight's homework. 3 things I need you to know before we start the assessment. The one that you know about, you can play back the video from yesterday. Tomorrow, calculator check, all 14 of you, 15 including Ivan, have to have a graphing calculator here. It needs to be able to turn on, right? A dead calculator does you no good. Let's make sure you have the graphing calculator, and as far as I know, it's not going to be a problem for anybody. Okay, there's that. There was a question yesterday about when are my tutorials? You guys know I get to drive to like all the different campuses and teach calculus all over the place and do all the things, which means I'm not usually here after school. I am going to be here during lunch Mondays, Tuesdays, Thursdays, and Fridays, 12:30 to 1. So that should be guaranteed time. If you need some support, come in, we can work on things. If you didn't do the homework, you're going to be coming in anyway, because then you're going to have to get it done. Don't laugh at him, it's going to be you two. We're going to spend so much time together. Oh my God, I can't wait. All right, we're good with the tutorial schedule? Good. All right, so if you guys could all turn to page 10, please. Page 10. On page 10, there are 10 problems that you're going to do. This is the formative assessment that I told you guys about yesterday. You may not use a calculator. You may not use your parent function survival guide for any of these. You have 5 minutes to evaluate all of these parent functions. I'm not going to say good luck, I'm just going to say enjoy the ride.
Oh.
Luck will not help you right now. Keep your eyes on your own paper. All right, I need to go have some tough love conversations. It's not good. No, Abraham's on the list first. It's alphabetical. You're second. Okay, 4.5 minutes. All right, I did not get the solution. Yes, that'd be great. Thank you. Hey, Juan. Okay. At lunch today, I need to stop by so we can send you an email. So I can make sure that you get solutions on the things. Also did not turn in, I don't know about two summers on that. I did stop by when I asked you to. So we need to tell you about that today for lunch. Okay, Kevin. Why am I leaving here? Kevin, I also need to send this one. I do not have a solution. It's okay. Round 1 and round 2 I did not get. We already have that one. Round 3 I also did not get. So I'm getting all of this by Monday. And if I don't get it Monday, then I earn so much money. You're going to know my lunch choices every day. Oh, hey, bro. How convenient. You guys are all sitting on the bed. Hey, bro. Okay, I didn't get round 1 or round 2. We'll talk about that. I didn't get round 3. Okay. Ivan is not here. What's that? You can sit on it, that's the great. Jackie. You don't understand. Okay, Jackie. One or two, we already talked about this. About 3 minutes. Okay, if I don't, I'm Carlos.
Wait.
Huh? Okay. I need you to stop by during lunch. This is going to take like 10 seconds for you to send me an email so I can make sure that you get all the information that you need, okay? I send a lot of email and things like solutions to help you study and things like that. So I need to see you at lunch. The other thing that I need to do, we already talked about round 1 and round 2 of the summer assignment. That you have until Monday to get those done. Okay, that would be a good thing for you to let me know about so I can do something. Okay, Jose. You also get this one all the time. Today, you're going to send me an email so that I can start doing all of that and you get all the things that everybody else is getting. So that you're not so lost every time you walk in class. Round 1 is going to be, round 2 is complete. Round 3 Neo, you're welcome. Okay, round 3 of the summer, something I didn't get from these. Ashley. Hi there. Round 3. That's by Monday. You okay there? You look like you got shot. So. One minute left. Hi, Jack. Oscillation? Isolation. Okay, shut up. Okay. Oh God, now I say shut up on camera. Time's up. Time's up. All right, so there are 10 problems. There are 14 of you all. What I need is volunteers that are willing to read the notation and then share their answer. You can pick any one of the 10 that you want. So you want to get in quickly before all the easy ones are gone. Delia, I saw you first. Which one do you want to do?
first one,
First one, I need you to read it and then tell me your answer.
the limit as x approaches 0 from the right,
Limit as x approaches 0 from the right
1 over x,
of 1 over x, and what did you write for your answer?
positive
Positive
infinity.
infinity. Everybody good?
Yeah.
Absolutely perfect. Other way to write it?
Yeah. Oh, no.
Oh, other way to write it, Jackie?
No.
You guys are just killing me. DNE, right? DNE because unbounded behavior. Perfect. Kaylin, pick another one.
Number 3.
Number 3, you like this one. Limit as x approaches infinity, cosine of 2x. What's that doing? Does not exist because of oscillation. OSCILLATION. Okay. Other ones, get in there. There's 8 left. Ashley,
2.
number 2.
Lim of x
Limit?
as it
Limit.
limit
Yeah.
of x as it approaches 0 from the left 1 over x squared.
Yep, love it.
It's positive infinity. Right?
Perfect.
Oh, okay.
Right, what you need to know, and if you don't know the parent functions, sketch them out. 1 over x squared looks like that. You're approaching positive infinity. Great, 3 down, 7 to go. If you've already volunteered, you're frozen, you can't volunteer again. And when I run out of volunteers, I go for victims. That's so much more fun. Jackie,
Number 5.
number 5.
Limit of x. Limit of x. Limit of x as it approaches negative infinity.
Limit as x approaches negative infinity of,
E to the the power of negative x.
love it,
0.
is going to be
0.
0. Does everybody agree?
See what?
No one disagrees? Just me?
Why?
Oh, okay.
What does the graph of e to the negative x look like? Can you guys draw that in the air? This is really important. E to the negative x. E to the negative x. E to the negative x. I think a lot of you guys drew this. That's e to the x. E to the negative x is a reflection. This is e to the negative x. So the limit, Jackie, now that you've got the right graph in front of you, limit as x approaches negative infinity, what happens with those y values? Right, positive infinity, or does not exist because of unbounded behavior. You have to know the graph. If you know the graph, these are easy. If you know the graph. All right, good. So that's 1, 2, 3, and 5. 6 left. Abraham.
Limit, number 8. Limit as x goes to infinity.
Yep.
Of 1 over x squared plus 1
Yep.
equals 0.
Love it. If you don't know what the graph looks like, it looks like that. It does that little hill thing. So as you approach infinity, the y values are getting close to 0. Nice. Okay. Give me one, Pedro.
Number 7.
Number 7.
The limit of x as it reaches the left side.
The limit as x approaches 0 from the left-hand side of the absolute value of x over x. What's that limit?
0.
0? Negative 1. Okay, let me give you a little bit of a nudge here, Pedro. The graph looks like that. So Pedro, one more time. What's the limit as x approaches 0 from the left?
Negative 1.
Negative 1. Way to make your voice sound like it came from a young lady. Okay, Jose.
Limit of e to the negative x as x approaches positive infinity.
What you got?
0.
0, right? Hopefully that's an easier one. Limit as x approaches infinity now that you've got the graph in front of you. Can we all agree on this?
Yes.
If you know what the graph is, the question's easy.
Yes.
The key is we got to know the graphs. Have to know the graphs. So that's 1, 2, 3, 4, 5, 6, 7, 8. And now I would imagine 9 and 10, no one wants to volunteer. Everyone's going to look down and hope I don't go for victims here. You're frozen. Okay, here's a little nudge. The graph of tangent of x looks like that. And it keeps repeating. It has a vertical asymptote at x equals pi over 2. So with that said, what's the limit? Limit as x approaches pi over 2 from the left of tangent of x. This is what the graph looks like. It's DNE, but why? Unbounded behavior. Specifically, we're going towards positive infinity, decreasing, unbounded behavior. Number 10, I'm not too worried about. This one you actually could plug in, or you could try plugging in. And some of you might get here and be like, that didn't help.
Yeah.
Right? Secant of pi. How am I going to find secant of pi? You can use the unit circle. You could do something that Mr. Link would have taught you to do. Something about secant. There you go. This is the same as saying 1 over the cosine.
Yeah.
Cosine of pi. Now if you think about your unit circle, right, here's the unit circle. Pi, you're on this side. The cosine of pi is -1, not 0. I would expect that 1 through 8 need to go well. 9 and 10 are the tough ones. 1 through 8 we can't afford for that to be the tough ones. Okay, last bit of good news. I am not picking this up for a grade.
Thank you.
Oh, now I get a thank you. Fine, be that way. Okay, I need you to know though, there is a quiz on Monday. The first part of the quiz, Evelyn, just so that you know, is 10 parent function questions just like this. Not to be confused with these 10 all over again. 10 parent function questions that you just need to know what the graphs look like. Okay? You need to spend some time with the parent functions. Alright, time for the push. We've only got 23 minutes left, and that's okay. I need you guys to take out your calculators. We're staying on page 10. What I've decided to do with this topic is after 3 years of trying to do this, I can tell you this is tough. This is a tough topic. You're going to be fine. You need a graphing calculator. If your graphing calculator is still charging, maybe you want to borrow one from somebody else. They'll never know. You probably want to go get a calculator if you don't have one. Okay, the topic is called graphical analysis. I don't know that anybody is worried about the phrase graphical analysis. What we're going to do is we're going to evaluate limits. Everybody good? The whole unit is about limits. Okay, but the problem is these are all going to be challenging. So I want you to have a quick conversation with somebody near you. When you look at problem number 1, what are your thoughts? What could you do to go about evaluating this limit? I'm going to take 10 minutes. I'll be back in a minute. Delia, are we still good with the camera?
Yes.
Good.
I don't know, because it's like
We're taking a break.
unbounded Just because it's code?
All right, I would love to hear from some folks. What ideas are out there? I'll take anything from anybody. You see this problem, first thought. Jose, what do you got for me? Okay. So, Jose says we can make a table of values. Right, we can graph it on the calculator, plug stuff in. How many guys are thinking like that's going to be your approach? Oh, okay, 3 people, 4 people. What else? What other things could you do? You're frozen. Did anybody try plugging in? Tell me why plugging in doesn't make sense. Right, if you plugged in, you're going to write something that looks like cosine of 1 divided by infinity. Can we all agree that doesn't even feel right to write this? Direct substitution, not the way to go. Another option might be, I can see Abraham, I can see the thoughts rolling. He's like, oh, it's a parent function. Do you know, Abraham, what the cosine of 1 over h looks like? I don't, other than the fact we graphed it 2 periods ago. It is not a function that you know what it looks like. You could build a table of values. In fact, why don't you guys take a minute and build a table of values. So over here, I'm going to like h, here's cosine of 1 over h, my goal is to approach infinity. Make sure your calculator's in radian mode. If you're not in radian mode, you can't do this. Yeah.
Can you put a video on it?
We can play back the footage to when I said if you don't have a calculator, you can go borrow one. But thank you. Respect to you too. Respect to your mom. Okay, if you looked at the graph, last period somebody described it as like Wonder Woman. But I think it would be like Wonder Woman. There's like a whole lot of W's happening there in between. Okay. If you look at the graph, you might start to get an idea of what's happening as we approach infinity. If we build a table of values, waiting for that stabilization, what are we seeing?
It just means that.
It stays at 1?
No, it didn't say one, but it was.
Hopefully you're getting answers like 0.99999. Is that what we're getting on the calculator? You should be. And so what that would tell me, I could see it from the graph, but I know that the limit is going to be 1. That's the final answer. You're getting 1?
That's what it said.
Yeah.
0.999.
Yeah.
0, and then I put 900.
Then you got it. Okay. I think what's happening is your calculator is rounding really quickly. 1 is the right answer, but you're not seeing the stabilization. Just give me a quick thumbs up when you get 1 as your answer. I see 1, I see 2. I'm worried about the friends in the back. The really quiet people in the back.
Oh, I got it.
You got 1, okay. Naomi and company. Are we good with getting 1? Okay, if that's true, I want you to try number 2 and number 3 on the calculator as well. I need to see that table of values, please. In fact, I want to change number 2. Limit as x approaches 4. Let's put a negative sign in there. You look like somebody needs a calculator. You've got one, so you can solve it for me. What you can also do is and then do zoom 6. So we've deliberately changed number 2 to the limit as x approaches 4 from the left. Zoom 6. Or, I'm sorry, zoom 5.
To the right, right? Left to right?
Yeah, no fixed.
What about
The number
Yeah.
for negative.
Yeah, for negative, it's like.
Okay, and then positive. So what would it be for negative 4?
Negative
What's
4.
with this
I
function?
mean, square
we're
root
gonna
of
do very
negative.
quickly.
What? It's 1
And I would say that, okay, you have stabilization
That's
here, it's
like,
1
but
point.
with, that's in
Okay,
fancy,
keep going with 2 and 3.
She knows.
Okay, friends over here, how are we doing?
We already, we don't know what numbers to plug in.
Okay, why not?
Okay. Because we're coming from the left, right?
Okay, you're coming from the left of 4. Give me an example of a number to the left of 4. 3 is an example of, but on the number line, here's 4, here's 3. Can you get closer to 4? 3.9 is closer to 4. Can you get closer? 3.99, 3.999. You need to get closer to 4.
Is it possible that you don't reach stabilization?
It is possible that you don't get stabilization. But if you see in the answer, something should be happening here.
I
I put 3.9.
Yeah.
3.16.
Right, what's happening with those values?
Just keep getting closer to the
They're
value.
getting bigger, bigger. So what's, what am I gonna make?
Put any number that's gonna be good.
Right, so because you're not actually getting closer to like a number, like if you were getting closer to like 10, you'd see 9.9, 9.99, 9.999, but the numbers just keep getting bigger. They're approaching infinity. They're just jumping.
No.
Okay, so the word on the street is, for this one, we should be getting positive infinity.
Yeah.
Those values are just getting bigger, bigger, bigger. If you haven't done it yet, limit as x approaches pi over 2 from the right. We're going to leave that as a mystery for right now. Alright, so we've got about 14 minutes left. We're going to put the calculators away, and I want to blow your minds a little bit. And we're going to play around with this tomorrow as well, because I can tell you this is the tough topic. This is the thing that doesn't make sense the first time through. So we know from using the calculator that 1 has to be the answer. Everybody's good? 1 absolutely has to be the answer. I want to show you a different way to do this. The first things I heard was, let's go to the calculator, and then I said, how about plug in? And you guys were like, that doesn't make any sense to do cosine of 1 over infinity. If you see something like this, this other approach that I'm going to show you is the way to think about it. It's called graphical analysis. What I'm going to do is I'm going to write it this way. As h approaches infinity. Right, I'm not writing limit up here, I'm just saying as the h values approach infinity, as they get big. Well, look at the function. What's the first thing happening in the function? I've got to look at 1 over h. H is approaching infinity. H is getting big. 10, 100, 1,000, a million, a billion. What happens to 1 over h? Is everybody okay? We're getting smaller? But smaller, like getting closer to what? 1 over h is getting small. Think 1 over 10, 1 over 100, 1 over 1,000, 1 over a million. We're getting close to 0. 0 is not the answer. 0 is telling me what's happening inside here. Now what I want to do is I say, okay, what about the next step? What about the cosine? The angle in here is getting closer to 0. What do we know about the cosine graph? If you don't remember the cosine graph, look at your parent function survival guide. What does that cosine graph look like? Right, it's the wave, but specifically it starts up here at the highest, and it does this. H is approaching infinity, but the angle gets closer to 0. What happens to the cosine if the angle gets close to 0? Here's the cosine graph. The angle, the input, is getting closer and closer and closer to 0. What happens to the y value? 1. So we're approaching 1. You don't need to know what the graph looks like. You can do, it's kind of like decomposition. We're pulling the function apart. I'm saying h approaches infinity. So what's the first thing to look at? It's this 1 over h. Oh, that gets close to 0. Now what's the next thing to look at? Cosine of something getting close to 0, and that gets close to 1. We've got like a day and a half to play around with this. It's gonna get better. All right, so let's try with the second one. Limit as x approaches 4 from the right of 1 over the square root of 4 minus x. You guys already told me positive infinity. Sorry, we changed it to the left. Okay, and you guys, most of you already found out on the calculator it's positive infinity. Let's do that same approach. As x approaches 4 from the left, the first place I'm going to look is underneath the radical sign, because that's the first place that the x shows up. X gets close to 4 from the left. What happens to 4 minus x? If you're not sure how to answer this question, pull up in your head a number to the left of 4.
5.
Left of 4. Oh God.
Yes.
Here's
3.
4.
3.
Left. Okay? No offense, you're participating. We'll go with that. So here's 4. 3 is over here, but I want to get close to 4. 3.9. 3.99. 3.999. What's happening to 4 minus x? Careful. X gets close to 4. 3.9, 3.99, 3.999. 4 minus x is decreasing towards what? X gets close to 4. 4 minus x gets close to 0. From the left of 0 or the right of 0? Negative numbers or positive numbers? Think about the number that we just picked, 3.9.
Positive.
4 minus 3.9 is going to be a positive, so you're getting close to the right. Now don't be fooled, not the answer. Right, that's just telling me what's happening underneath the radical sign. The next thing you want to look at is, well, what about that square root? What happens to the square root of 4 minus x? 4 minus x gets close to 0. Take the square root of something that's almost 0. And if you're not sure and you need to plug it on the calculator, feel free. Take something close to 0. Take a square root. You're going to approach 0. 0 is not the answer. And it's not the answer because we still then have to figure out, well, what happens to 1 divided by the square root of 4 minus x? The square root of 4 minus x, we just decided, is getting closer to 0. 1 divided by something close to 0. And if you're not sure, try it on the calculator. What were we going to say? Closer to 0, try it on the calculator. Try 1 divided by something close to 0. We've got to work on the number set skills. I think this is part of the problem. Try it on the calculator. 1 divided by something really close to 0. 1 divided by 0.1. 1 divided by 0.01.
10.
You've got 100. You've got 1,000. Other people, 10,000. What's happening? The denominator is getting closer to 0. 1 divided by something almost 0 bigger. What's happening here?
It's reaching infinity.
Reaching infinity. Guess what?
That's your
That's your answer.
wow.
I didn't know what the graph looked like because I didn't get a chance to graph it on the calculator, but I said, let me start by picking a number close to 4, and let me work on the inside, and then work my way to the outside. I'm trying. All right. I'll tell you number 3, if you did this on your calculator, your answer is going to be negative infinity. Try these newfound skills. See if you can reason your way through why it has to be negative infinity. Use that parent function survival guide if you need to. There is zero shame with that. X is approaching pi over 2 from the right. The first place I want to focus on is the tangent. What happens to the tangent? You're getting close to pi over 2 from the right. What's that graph doing? You've got to be able to read that parent function survival guide. Actually, do you have yours?
Yeah, you can do it.
So x is approaching pi over 2 from the right. If I approach pi over 2 from the right, what's happening to tangent of x? They're heading towards negative infinity. Now, last class they were like, oh, that's why it's negative infinity. We're not done yet. All we figured out is what happens with the tangent of x. Now we need to go one step further and say, what about x times the tangent of x? The x values get close to pi over 2, some positive number. The tangent of x is getting closer to negative infinity. Pi over 2 times something getting close to negative infinity? Is it ridiculous? It's still negative infinity. Right? X is approaching pi over 2 from the right. Tangent of x approaches negative infinity. But something getting close to pi over 2 times something getting close to negative infinity has to be negative infinity. So your final answer, I just want to make sure we write this out. The limit as x approaches pi over 2 from the right of x times tangent of x is negative infinity. Naeem, what's the other way that you might want to write this?
Up on the front.
Yep, phone a friend.
Does not exist for
Yeah.
unbounded behavior.
Does not exist because of unbounded behavior. All right, smarty pants. Let's see what you can do with the last one. If you'd like to use your calculator, feel free. Nobody seems to be reaching for their calculator. Why not? I'm curious. I think there's a good reason why no one's reaching for their calculator. Jackie, why do you think no one's reaching for the calculator here? Okay, maybe they have high expectations. They want to learn how to do it by hand. I think there's another reason why no one is actually reaching for their calculator right now. Delia, why is no one reaching for the calculator?
Because we don't know what to put, or
You don't know what to put for what?
A?
For A, right? A is a variable. It's not a number. The fancy word for A, this is a parameter. I want to make sure you guys get that in your notes. It's a parameter. It's a constant, but they haven't told you what the constant is. Did they tell you anything important about the constant? They did tell you something about the parameter. It's less than 0. So I've seen some students that have said, well, if it has to be less than 0, then maybe what I want to do is like pick some number less than 0 and just see what would happen. You can do that if you want to. We've only got 1 minute left, so let's see if we can do this. As x approaches 0 from the right, what do we know about the natural log of x? You need to know that graph. Natural log of x, what's it doing if you approach 0 from the right? I heard 0, I heard negative infinity. If you're not sure, natural log of x looks like that. What happens if you approach 0 from the right? Negative infinity? So as x approaches 0 from the right, the natural log of x approaches negative infinity? Not the final answer. You've got to tell me, what about a times the natural log of x? This part approaches negative infinity. A is a negative number. It doesn't matter what negative number it is, we just care that it's a negative number. So a negative number times negative infinity, everyone can tell me is?
Positive infinity.
Positive infinity. Well done. So the best answer, limit does not exist because of unbounded behavior. Tomorrow, we are just going to practice these skills and get really good with the writing and the analysis piece. Tonight's homework, good news, has nothing to do with this. I wasn't ready to push you guys in this direction for homework. I want you to be able to do what you should have done last night with greater levels of success. I'll see you guys later. If anybody needs help, or those of you that need to stop by and see me, I'll see you at 12:30.